Hello, this is question 4 on your November 2021 paper 2 from OCR. It says the size P of a population of a certain species of insect at time t months is modeled by this formula. Write down the maximum size of the population. So we have a trigonometric function, which means we are able to find a maximum and minimum easily. We know this is going to be maximum when this is minus 1, because this is oscillating between minus 1 and 1. When this is minus 1, this becomes plus, and we are adding 5,000 plus 1,000. Yeah, so P max when cos is 1, yeah, is minus 1, sorry, is going to be 5,000 plus 1,000, which is 6,000. And that's the size of the population. So I would say we can say insects if you want, just in sets. Yeah. For B, it says write down the difference between the largest and the smallest. So we know the largest, the smallest is going to be when this is 1, because when this is 1, I'm subtracting 1,000. So the minimum when cos is 1 is going to be 5,000 minus 1,000, which is 4,000. So the difference is 2,000, yeah, between the maximum and the minimum. C, without giving any numerical values, describe briefly the behavior of the population over time. So we have a constant and then something that is oscillating, yeah, because cos is going to be going up and down, so the population is going to be oscillating. Yeah, we can say is fluctuating, or is I would say just oscillating. Yeah, population is oscillating. Oscillating with time. D, find the time taken for the population to return to initial size for the first time. So this is the initial population is when t is 0. Yeah, so we are going to find that one, and then we are going to see when that happens again. And this is D, no? D. So next one is D, this one was C. When t is 0, so at the beginning, we have that population is going to be cos 0 is 1. So we have 5,000 minus 1,000. So 5,000 minus 1,000, we can write cos 0 if you want. This is 4,000. That's the initial population. They are asking us when the population is again 4,000. So we are just going to solve the equation. Minus 1,000 cos 30t. Yeah, that's what we have to solve. We have 4,000 minus 5,000 is minus 1,000. It's going to be minus 1,000 cos 30t, which means cos 30t is 1. Yeah, and that happens when t is 360. That's the second time. Yeah, when t is 360, the population is going to be, we are going to, wait a minute, so 30t, so no, sorry, this is 30t, not t. Yeah, 30t is going to be 360, which means that t is going to be 360 divided by 30, 12. And the time is measuring months, so that means that after 12 months, my population is again the initial one, which was 4,000. Yeah. Then E, it says determine the time on the second occasion where P is 4,500. Again, we are going to substitute in the equation and find that out. So we need P 4,500, but not the first time, the second one. So P is 5,000 minus 1,000 cos 30t, and this is going to be equal to 5,400. 5,000, sorry, which means minus 1000 cos is going to be 4 minus 500. So that means that cos 30t is going to be 1/2. And cos 30t is 1/2 means that 30t is 60 degrees. And that means that t is 2. So 2 months. That's the first time. They ask us the next time. And the next time, we are talking about the cos. So the next time is going to be 360 minus 60, which is 300. So the next time is 300 divided by 30 is 10. So the second time is 10 months. And that's my answer, not the 2 months. Yeah? That's the first time and the second time. Then a scientist observes the population over a period of time, and he notices that although the population changes in a way similar to what was predicted before, so to this one, the variations become smaller and smaller with time, and P converts to 5,000. It suggests a change to the model that will take account of this observation. So remember, that's not an uncommon question. That when we have an exponential with negative exponent, our function is doing something like this. No, sorry, something like this. So it's decreasing and it has an asymptote. If we want to include, or we want to make this function to decrease with time, what we can do is this one that is oscillating multiplied by e to the power of minus x, for example, because then that way our function is going to be oscillating. Yeah, so the cos is this function, but it will be oscillating and the waves will be smaller and smaller. Yeah, that's how we do it. I think it's something that it's difficult to deduce if you don't know, so it's something that maybe is useful to know and to remember. So if our model could be something like the 5,000 that we had minus 1,000, and then multiply the cos by this not x, we have t, yeah, and that's all with this question. Yeah.